about how long your project will really take. We'll be looking at linking, task flows, and estimating. Tomorrow we will talk about how to get the work done on the project by discussing in details working with resources in Microsoft Project. The format for this webinar is that I will go through some explanation of the topics and then we'll demonstrate the functionality in Microsoft Project. We will also have some specific spots where I stop for questions. So at any point if a question comes to mind, just go ahead and type it into the question chat box and I'll address them when we get to the Q&A. I'm going to be working in Microsoft Project standalone for our sessions. However, almost everything I talk about applies in exactly the same way to Microsoft Project with Project Online and Project Server. I'll mention any differences as we go through the session. So as I said, today we're going to focus on setting up our schedule model, making estimates. We want to determine how long it's really going to take us to do this project. We'll be covering setting up links between tasks to simulate the workflow for our project. We'll talk about lags and leads, which allow us to delay or accelerate the successors in our links. And we will talk about different approaches to estimating tasks, including duration and work. Links allow us to model which tasks can take place in parallel and which must take place in series. The links are established by looking at the required inputs for a task and matching those to a predecessor task that produces that item as an output. Our links allow us to build a schedule model that simulates the work of the project. When we talk about links, we are always talking about the links between two tasks or between tasks and milestones. The first task is called the predecessor, and the second task is called the successor. Excuse me. There are three main categories of links that we need to consider. The first is mandatory links. Mandatory links are those that are driven by matching required inputs to outputs. Mandatory links are based on the nature of the work. So for example, if I have a task called test unit, I have to have the unit before I can test it. So I'm going to link that to the task that builds the unit. The next category of links is discretionary links. Discretionary links are links that are defined based on best practices or other information. They are not driven by input requirements. So for example, if I'm building a house, I may have a task that is to paint the exterior of the house and another task that is installing the landscaping. It's not mandatory that the painting be completed prior to the landscaping, but it would be better not to have painters traipsing through when the landscaping is going on. So I might want to go ahead and create a discretionary link between those two tasks. Discretionary links need to be well documented because there may be reasons to revisit and change them if schedule challenges occur. For example, if my house starts running late, I may need to find a way to work those two tasks in parallel. The third category of links are external links. External links are links with tasks outside of the project. These are typically modeled with a milestone that represents the receipt of the item that is coming from outside. You will typically assign a start no earlier than date constraint on that milestone that represents the date you expect to receive the item. So for example, if you're receiving a battery from an outside vendor, that could be represented as an external link in your schedule. This type of link needs to be monitored carefully to identify any potential impacts coming from external sources. You need to make sure that you get status on that delivery in case something changes. We will be focusing primarily on mandatory links. There are three commonly used types of links: finish to start, start to start, and finish to finish. There's also a fourth kind that is not commonly used and typically not recommended that is called a start to finish. For finish to start links, the predecessor must finish before the successor can start, or you can think of it as the successor cannot start until the predecessor finishes. This means that the earliest the successor can start is immediately following when the predecessor finishes. For start to start links, the predecessor must start before the successor starts, or you can think of it as the successor cannot start until the predecessor starts. This means that the earliest the successor can start is at the same time that the predecessor starts. For finish-to-finish links, the predecessor must finish before the successor finishes. Or you can think of it as the successor cannot finish until the predecessor finishes. This means that the earliest the successor can finish is at the same time that the predecessor finishes. The pictures on the far left of the screen show these examples in standard schedule modeling format. The smaller pictures in the middle show what the links look like in Microsoft Project. They're time phased. We're going to look at each type of link in a bit more detail. So starting off with finish to start. Finish to start is by far the most common kind of link. In fact, in a detailed schedule, at least 90% or more of your links should be finish to start. Some people build their models exclusively using finish to start links. Finish to start means that A must finish, our predecessor, before B, our successor, can start. So an example of that, as I mentioned earlier, would be building the unit before we test it. Start-to-start links are a way to model parallel work. Some part of the tasks can be done at the same time. When A starts, B can start. B can start at the exact same time as A or later if something else drives it to be later, but it can't start before A. An example of that would be writing code and testing code. I don't have to wait till I'm completely done writing the code before I start testing it, but I certainly can't start testing until after I start writing. Finish-to-finish links also model parallel work. There's some part of the task that can be done at the same time. When the predecessor finishes A, then the successor B can finish. B can finish at the exact same time as A or later if something else drives it to be later, but it can't finish before A. So an example of this would be integration and test. I may be able to start my testing before I have completely finished my integration effort, but I certainly wouldn't be able to finish my testing until after the integration is complete. Lags are used to delay the successor task in a link. In a start-to-start or finish-to-start, it delays the start of the successor. In a finish-to-finish, it delays the finish of the successor. Lags should represent effort. In a start-to-start, the lag represents the portion of the predecessor that must take place before the successor can start. This is used to model that there is some work taking place in those first days that needs to be complete before the successor task is able to begin. So in the example on the screen of the write code and test code, what we're modeling here is that we've determined that once we have 10 days of code written, we then can start testing. So that's what my start-to-start with the lag of 10 is representing. In a finish-to-finish link, the lag represents the portion of the successor that cannot finish until the entire predecessor is complete. This is used to model that all the work in the predecessor must be finished before the last portion of the successor can complete. And in my example on the screen, we have the integration and test tasks, and what we've modeled here is that the last 7 days of testing cannot take place until our units are fully integrated. So that's what my finish-to-finish with the lag of 7 is representing. We recommend as a best practice that start-to-start and finish-to-finish links should typically have lags associated, and that finish-to-start links should typically not have lags. I want to talk a little bit more about putting lags on finish-to-start links. What we've suggested is that typically they should not have lags. Usually people put lags on finish-to-start links for one of two reasons. They think that what they're representing is an insignificant effort. So for example, we have a task called pour concrete, and we know that we can't start framing the walls until the concrete has had 10 days to cure. Often people will put a lag in to take those 10 days up before we start framing the walls. However, it's much better if the lag represents something happening even if it seems unimportant, to go ahead and add a task. That way you have the visibility to what's going on, and anyone else looking at your schedule will also understand what those 10 days are representing. The other reason that people typically put a lag on a finish to start is to push out the successor, or what we call to force a date. So in this example, we have a task called install components, and the task that follows that is a wind tunnel test. Well, we know that the wind tunnel is not going to be available to us until June 12th. So oftentimes what people will do is they'll put a lag on the finish to start link to push that wind tunnel test task out to start on June 12th. The problem with that is that if then the predecessor ends up getting delayed, the install components, the 7-day lag continues to exist and continues to be included in the calculation for the start of the successor. So the wind tunnel test, even though the wind tunnel is available on the 12th, is now not scheduled to start until June 21st. A better way to handle this kind of a scenario is by using a start no earlier than. So what we've done is we've applied a start no earlier than date to our wind tunnel test of June 12th. What that's done is it's pushed out the wind tunnel test past the end of the install component so that it's originally scheduled to start on June 12th. Then, if the install components task should get delayed, it will not push out an additional 7 days. What it will do is it will just take into the calculation that start no earlier than date. So now we have the wind tunnel test starting immediately following the install components. So these are the two reasons that people typically put a lag on a finish to start link. And as I just showed you, there are better ways to work with that kind of a scenario. Lead is an acceleration of the successor. So we talked about lag, which is a way to delay the successor. Lead is a way to accelerate the successor. You can think of lead as negative lag, and that's actually exactly how we enter it into Microsoft Project, as a lag with a negative value. It's much less common to see a lead than a lag. I've rarely used them in 30 years of building schedule models, so they're not something that is commonly used by most people. By defining our tasks and the links between them, we are building our schedule model to represent how our project will be performed. We need to make sure that every task and every milestone has at least one predecessor and one successor. We don't want any hanging ends or any hanging starts. The exception to this is the start or finish of the project, or if we have an external link represented in our schedule model. A good schedule model gives us the ability to predict the project's schedule outcome. We can be at any point in the project and forecast an end date based on logic and durations. Because we're able to use the model through the life of the project, we have the ability to mitigate potential schedule issues before they happen. The further in the future we can identify a potential problem, the more options we will typically have to resolve it. So for example, if I have a schedule model that I've kept up to date, it truly represents how I'm planning to do my work, I've put status on it appropriately. If I use that schedule model and I can see that 6 months from now in June, I have 4 weeks where I have enough tasks scheduled that I need 6 technicians to be working on my project, but I only have 3 technicians that have been assigned. Because I know this so far in advance, I may be able to acquire more technicians from the resource owner, or maybe I can subcontract some work out, or if it's an ongoing need, maybe we just hire more technicians. If I don't know about this problem until the day I walk in the door and I have 6 tasks that are supposed to take place starting today and only 3 technicians, I am definitely going to take a hit to the schedule of some of my tasks and very possibly to the end date of my project. We always link detailed tasks. So what we'll see in just a moment is we're going to be linking down at the lowest level of detail. Summary tasks should not be linked. There are lots of different ways to link tasks in project. We're just going to look at a few of them, and then I'm going to demonstrate them in project. So the first way I want to talk about is just using the link and unlink buttons. So these can be found under the task ribbon, and they are just these two little pieces of chain link. This is the link button, and then the broken chain link is the unlink button. Another way of working with links in Microsoft Project is using the task entry view. The task entry view is actually a split screen, and then what I can do is I can actually format the bottom pane, the bottom part of the view, so that I'm looking at predecessors and successors for any task. So in this example, I currently have selected the frame and fork complete task. And down here in this bottom, I'll see all of the predecessors for that task and all of the successors. So it's a way that I can view information as well as enter links. I can just type in the ID number of the additional predecessor that this task needs, click on OK, and it will add that link. The third way and final way that I want to show you about linking in Project is the predecessors column. So we actually have a predecessors column and a successors column. And as I'm entering links into Project, Project will automatically be filling in the information in this column. I can actually type directly into the predecessors column if that is the way that makes the most sense for me. I just want to point out a couple of things about the format. So if you look here down at task 11, you'll see that it says 9FF plus 2D. If I see just a number in the predecessors column, Project has set up, or what we have set up, is a finish to start link with 0 lag. If we have any kind of link that either isn't a finish to start or doesn't have 0 days of lag, then I'll get a format something like we see in task 11. So this is telling me that task 11 has a predecessor of task 9. It's a finish to finish link with a 2-day lag. We're also seeing a comma and the number 8 here. That tells us that we actually have 2 predecessors for task 11. We also have a predecessor of task 8. So whenever you see commas and multiple values in your predecessor column, that's the way that you know that you have tasks that have multiple predecessors. Okay, so now we're going to take a look at some of the ways we can link tasks. So what I have here is a project that just has a task list, and we're going to look at some of the ways that I just mentioned that we can do linking. So the first way is we're just going to use the link button. So again, that's found under the task ribbon, and it's under the schedule section. It's the chain link and then the broken chain link. So this is our link and this is our unlink. So the way I can work with the link button is I can just click and drag through 2 tasks that I want to link, click the little piece of chain link, and Project will automatically, by default, set up a finish to start link with 0 lag, which is perfect because, as I mentioned earlier, 90% plus of your links in your model should be finished to start with 0 lag. I can unlink those tasks. If I decide those were not really the ones I wanted to link, I can unlink them just by clicking on the broken chain link, and Project will remove the link that I just created. I can link more than 2 tasks just by selecting, holding down my mouse button and just dragging through all the tasks that I want to link. Press my link button, and what Project will do is it will create the links from top to bottom here, finish to start, finish to start, finish to start. I'm going to go ahead and unlink those. I can also link tasks that are not directly adjacent to each other. And the way I do that is I click on a task, I hold down my control key, I click on another task, and I can click on more than 2. I can continue to click on all the tasks that I want to be linked. And then when I click the link button, what's going to happen is Project is going to link them, finish to start with 0 lag from top to bottom. It's important to know that when you're using the control click, when you're linking non-contiguous tasks or non-adjacent tasks, the Project is going to link those in the order that you select them. So if I started down here and selected this task first, held down my control key, selected another task, and then clicked the link button, Project is going to link them in the order that I selected them. So it's not going top to bottom when I'm using my control click. What it's doing is it's recognizing the order that I selected the tasks and linking them in the chain in that way. If I decide that I want something other than a finish to start link, I can change a link that's been created by double-clicking on the link in the Gantt chart. So when I double-click on this link, I'm going to get a dialog box that looks like this. It's going to show me the predecessor, it's going to show me the successor, and then it's going to show me the type of link that was created. So what I can do is I can click on this down arrow, select the appropriate kind of link, add a lag, click OK, and Project will change the link to represent what I just selected. And we'll see it here in the predecessor column. The next approach that I want to show you is using the task entry view. So there are a number of ways I can display the task entry view, but one of the easiest is just clicking on the View tab and selecting Details here under Split View. So when I select that, what Project does is it splits my screen so that I have two different views visible. In the bottom, I have currently, by default, the format resource name and predecessor name. But what I would really like to look at is I would like to look at predecessors and successors. So I'm able to change the format, the information that's shown down here in this bottom pane, just by clicking my right mouse button over here in the gray area. And I'm going to select the predecessors and successors option. Now what I'm looking at is for whatever task I have selected in the top pane, it's going to show me the predecessor and successor for that task. In addition to showing me what's already been created, I can add additional predecessors or successors just by typing in an ID number, clicking OK. Project will go figure out what the rest of the information is that needs to be put in there, and it will add that link. I could do the same with successors. Whoops. I can add successors that I want for that task just by typing in an ID number. Clicking OK. Whoops. Sorry. Okay. It will tell you if you've already linked something and it won't let you relink it, so that's was a good little warning message. So again, I can use the task entry view to both view links that currently exist. I like to use it sometimes to sort of trace through the different task linking, so I find it to be a helpful way in that. The last thing I want to do is just look a little bit more at the predecessors column. So I'm going to go ahead and close the bottom pane down just by unchecking details under the view ribbon. And I'm going to scroll down here, and again, what we see are a lot of our tasks are only going to have a single predecessor and a single successor. And most of our tasks will be linked finish to start with zero lag. This is an example of a task that has multiple predecessors. This is an example of a task that is linked start to start with a 5-day lag. Okay. All right. I think, Amy, do we have you back? Do we have any questions at this point?
No, we do not have any questions at this point.
Okay. So if you have questions, just go ahead and type them into the chat box, and we'll go ahead and continue on. Now we're going to start talking about estimating. As we get into estimating, things start to get a little more complex. I'm a firm believer in the walk, jog, run approach to working with Microsoft Project. If your organization is brand new to Microsoft Project and developing schedules, it makes sense to focus, or it may make sense to focus first on task management only and later move on to managing resources. Give your organization time to gain skills and familiarity with building models using tasks, links, and duration estimates. Then once you have a solid foundation, you can move into working with resources and other more advanced functionality of Microsoft Project. I've worked with organizations that are doing strictly task management with Project Standalone or with Project Server, Project Online, that have then, after some period of time, started implementing resources into their schedules and processes. It can be very challenging if you try to jump into the middle of everything right from the beginning. There are two main ways that people think about estimating. The first is duration, or span time. How long will it take from the time you start until you will be done with the task? So for example, you may get an estimate from someone that says this task will be complete in 2 weeks. If you're doing task management only, you will always be doing your estimating using durations. You can also use duration estimating if you're working with resources. The other way people think about estimating is with what we call work or effort. And this is estimating man hours. So for example, you may hear, this task will take 16 hours of work or effort for me to complete. In both cases, if you're incorporating resources into your project, the units or percentage of time that you're working on a task will affect how long the task actually takes. Deciding how to enter estimates will be affected by what data is provided by your team members. If you're working with resources, you will always be providing 2 values to Microsoft Project, and then it will calculate the third. So for example, you may receive an estimate that says, it will take 1 week for me to complete this task, but the total effort will be 10 hours. So that's an example where you're given a duration and a work estimate combined. Or you may get an estimate that says, it will take 2 weeks for me to complete this task because I can only work on it 25% of my time. That's an example of getting a duration and a units estimate. Or you may get an estimate that says, it will take me 20 hours to complete that task and I expect to have 50% of my time to devote to it. Or maybe someone will say, it will take me 15 hours of effort to complete the task, and they won't specify what percentage of time they're going to be working on it. That's something that will be determined when the information is entered. So we're going to be working tomorrow with actually creating and applying our resources to our tasks. What I want to do today is give you an introduction really to the results that you'll see. So based on different options that you set up in your tasks. So we're kind of in a little bit of a chicken and egg thing in terms of which comes first. But as we talk about estimating, you need to start thinking about how I'm going to get my information. What kinds of information do I need to get from my team members to basically make the project be set up the way I need it to. If I'm estimating using task durations, there are a number of key points that need to be kept in mind. The duration should be estimated by the work performer. They are always the person that's going to know best how much time, how long it's going to take them to complete a task. If that person's not available or hasn't been assigned yet, you should later validate the duration with them once they've been assigned to the project. The duration should be the best estimate of how long it will take with all of the information that you currently know. It should not be based on when someone else says it should be done. So when you're first building your schedule model, what you want is reality. What you want is truth. I've worked in a lot of organizations where because they're given the end date first, they end up doing their estimating to fit within the due date. That's not where you want to start. That may be where you have to end up, but initially you want to know what it truly looks like based on everyone's best estimates and best information at this point. And then you can figure out, if necessary, how to bring in the end date. Your task duration estimate should be based on realistic resource level. So if you're doing task duration estimating, but you're actually working with resources, or really, even if you're not, whenever you estimate a duration, you always are estimating it based on an assumption of a certain level of resource assignment. So if I tell you something's going to take me 5 days, in my mind, I'm assuming some percentage of availability that I'm going to have to work on that task. So maybe I'm assuming I'm going to be working on it 100% of my time, or maybe 50% of my time. What we want to do is make sure that people are doing their estimates based on what is reasonable for the environment. And also, ideally, you want to document what that assumption is. So if someone tells you it's going to take 5 days, you probably want to understand how much time they think they're going to be working, or what the percentage of their time they're expecting to work on that task. And then finally, the duration is a span time in working time units, typically in days. So if I tell you, excuse me, something's going to take me 10 days to do, what that means is 10 working days, and therefore 2 weeks. If I'm estimating using resource work or effort, some of the same key points need to be considered. So just like with duration estimates, estimates should be estimated by the work performer. Again, they are the person that is closest to the task. They most know what it's going to take to accomplish the task. And it should be the best estimate of hours required. Again, so what do we really think it's going to take to accomplish the task? Not how much time do we really think we're going to be given or that we have or that helps us meet that imposed end date. Often I get asked, excuse me, often I get asked how much detailed tasks should be broken down into. There's not a single correct answer. It really depends on your environment and how granular you need your information to be to manage your project. There are, however, some rules of thumb that can be used to guide your estimating. A couple of the ones I see most often include what's called the 880 rule. So the 880 rule is a way of estimating work. And what this means is that no task should be less than 8 hours of effort or greater than 80 hours. For durations, a common rule of thumb is that no duration will be more than 2 update or reporting periods. Typically, organizations have a standard update cycle. If your cycle is weekly, then what this means is that no task would be greater than 2 weeks or 10 working days. In this way, no task should be in progress for more than 2 status cycles. These rules of thumb are simply guides to help you think about how much detail to break your work down into. If tasks are broken down into too much detail, you can end up with so many tasks that you spend all of your time managing the schedule data instead of managing the project. However, if you don't break your tasks down into enough detail, you can easily lose visibility to the early stages of a problem occurring. It's really common for a task with a long duration to be reported right on schedule all the way up until just before it's supposed to be finished. People always think they're going to be able to catch up. If we break our tasks down into smaller measurable pieces, potential issues can be seen earlier, and we'll be able to catch them before we've really slipped the schedule. Most important of all is to remember that these are estimates, and they need to be communicated as such. In some environments, as soon as you put a duration or a work estimate out there, it becomes a commitment, and any change is viewed as a problem or as bad planning. Estimates are made with all of the information that you have at that moment. It's not unusual as work progresses to get insight into better estimates for future tasks. We're not going to be talking about statusing in this webinar series, but one of the things that I teach in my regular training courses is that one of the things that you're going to be gathering for status is to capture any revised estimates for future tasks that are based on things that you have learned since the original estimates are made. So estimates, keep using that word so that people recognize that that's really what these are. Tasks are calculated using the values in 2 task fields. There's type, which is sometimes referred to as task type, and effort driven. Type can have one of 3 values: fixed duration, fixed work, or fixed units. Whatever you fix, Microsoft Project will hold constant and will not change it. Effort driven is a flag field that can be set to either yes or no. Now, as I mentioned, today I'm introducing some of the concepts surrounding work from an estimating perspective. We're going to look at the results of using various task types and effort-driven combinations. Tomorrow we'll go into the details. This slide just shows the combinations of those 2 fields that are available. So fixed duration and fixed units can have the effort-driven flag set to either yes or no. Fixed work will always have effort-driven set to yes. Project will not allow you to set that to no. There's a formula that includes these three values that Microsoft Project will hold constant for task calculations, and that's duration times units equals work. If one of these variables is changed, then Microsoft Project has to recalculate another in order to keep the equation balanced. In Microsoft Project, the assignment level is the intersection between a task and a single resource assignment. So if a task has two resources working on it, there are actually two assignments or two assignment level records for that task. There are two different units fields that exist at that assignment level. There's assignment units and peak, sometimes called peak units. The assignment units field can be thought of as the percentage of time that a resource is initially assigned to a task. So if part of the information that you receive as an estimate is a percentage of time that the resource will be working on the task, that percentage should be entered into the assignment units. If you don't enter a value into the assignment units field, then it will be set automatically to the maximum availability. It's a field called max units from the resource sheet. We'll talk more about max units tomorrow. The assignment units value will never be changed by Microsoft Project. It will only change if you manually change it. The other assignment level units field is peak. Peak can be thought of as the current percentage that a resource is assigned to work on a task. If you enter an assignment units value, Microsoft Project will initially set peak equal to that assignment units. The peak value, however, is the one that may be recalculated by Microsoft Project in order to balance the formula. So if you change duration or work, Microsoft Project may need to recalculate the peak units value. You cannot directly modify the peak units value. It is always a calculated value by Microsoft Project. This slide shows how Microsoft Project keeps the equation balanced. So if I have a resource assigned to a task and I make changes to it, make changes either to the task or the resource, these are the results that I'll get based on the task type that is assigned to that task. So for example, if I have a fixed duration task type and I revise my assignment units, I make a change to my assignment units, then what Microsoft Project will do is it will recalculate the work for that task. If I revise the duration, it will also recalculate the work. If I make a change to the total work, then it's going to adjust the peak units. So I'm not going to go through each of these. I'm actually going to do a demonstration in just a moment and we'll take a look at the differences. But just know that depending on the task type, when you make a change to one of the three items in the formula, Project is going to have to recalculate something else, and it's going to do that based on what task type you have assigned. Now, we also talked about effort-driven. The impacts of the effort-driven flag field are most visible when we put additional resources onto a task. So when I add an additional resource, based on what the effort-driven flag is, that will have an impact on what happens. So when I add an additional resource, if the effort-driven flag is set to no, which it can be for either fixed duration or fixed units, if the flag is set to no and I add an additional resource, then the total work on that task will increase. If the flag is set to yes when an additional resource is added, the existing work hours will be spread across the resources. And then for fixed work and fixed duration tasks, the peak value is recalculated. For fixed units task, the duration changes. So you can think about the effort-driven flag as telling Project whether you want to spread the existing work across the resources, that the existing resource plus what you're adding, or whether you want it to increase the work for this new resource. So my recommendation to you is that you use the task type or types that works best in your environment. Again, tomorrow we'll be covering working with resources in detail. So we'll talk about how to create the resource pool, how to assign resources, etc. And once you've done that, what I suggest is that you test these out, and I'm going to show you, I'm going to demo what the results are. But I suggest that you make yourself some small test projects, play around with these, think about what information you're getting from your team members, what your expected results are, and take a look at what task type and what effort-driven value really makes the most sense for you in your environment. Okay, so I'm now going to demonstrate some of the concepts that we just discussed. So first what I'm going to do is just some duration estimating. I'm going to enter some duration estimates, then I'm going to demonstrate how the task calculations vary based on task type and effort driven. So what I've done here is I've just opened a project that has links in it already. So if you notice, all of the detailed tasks are currently showing a duration of 1D question mark. So that's the default that project will put in there when I start entering tasks, just to tell me that this task doesn't have a duration put on it yet. So what we need to do is we need to enter for each of these tasks what the estimate is that we've received from the people performing the work. Sometimes duration estimates are done prior to linking, sometimes they're done after linking, so it doesn't really matter. In addition, in this little partial project, I have some items that are milestones, so representing milestones in my project. So for a milestone, what I'm going to do is I'm going to set the duration equal to 0. And that's what tells Microsoft Project that something is a milestone. So when I set these to 0, what Project will do is it will change them into a little diamond, and they have now become milestones in my project. So I just need to go through and start entering the estimates that I received from the team members, from the people who are actually going to be performing the work. And Project will adjust the start and finish dates based on the information that I've entered. Now, a couple of things I just want to point out here, and one, primarily because there's often a lot of confusion about it. So we have, in this project, we have some summary tasks. So for example, frame and fork is one of our summary tasks. I want to just explain to you how the dates and the duration are calculated for summary tasks, because this is often a point of confusion. So a summary task start is going to be set equal to the earliest start date for any of the subtasks, so any of the detailed tasks that fall underneath that summary task. The finish of a summary task is going to be set equal to the latest finish of any of the subtasks. So in this case, our earliest start is January 7th, our latest finish is January 28th. Then what Project will do is it will actually calculate the duration. And it will calculate the duration based on the number of working days in the project calendar between the start and the finish. So what you'll see is, even though underneath we have a 2-day task and a 3-day task and a milestone, excuse me, the duration of this summary task is 16 days. Oftentimes people are expecting it to be 5. They're expecting it to be the sum of the subtasks, but that's not how the summary task works. So I just wanted to point that out. Another thing that I want to mention, and this is one that I've seen often, is that if you type a duration, Project will allow you to type a duration for a summary task. But if you type a duration, what's going to happen is Project is going to automatically change that task from an auto-scheduled task to a manually scheduled task. So sometimes people will accidentally type in a duration for a summary task. We talked yesterday in our project options about the fact that we want to always use auto-scheduled because we want our schedule to be dynamic. We want it to be able to show impacts when we make changes. So what's happened here is, by typing in the duration on this summary task, it has flipped that summary task automatically into a manually scheduled task. So if I do that and I happen to notice it, all I have to do is click in that cell, go back, and reset it to auto-scheduled, and it will redo the calculations as it's supposed to. Okay. Now what I want to do is take a look at the effects of the task types, and then we'll look at the task types in combination with the effort-driven. So what I've got here is I have 3 tasks, and each of those tasks has 1 resource assigned. So I'm in what's called the task usage view. So the task usage view will show all of my tasks, and it will show all of the resources assigned to the tasks. So what you'll see here is that right now, they all look the same. They all have a 5-day duration. The design engineer has 40 hours of work assigned to them, and both the peak units and the assignment units are set to 100. I've named the tasks by what task type they are, so we can easily see it here. So what I want to do now is show you what happens when I go through and change the 3 different values that are part of that formula. So the first thing I'm going to do is I'm actually going to change the assignment units. So again, I have the ability to change the assignment units. Project always calculates the peak. So if I go in here and change my assignment units for each of my tasks to 50%, you'll see a difference in the results. We have a fixed duration task, so it held its duration at 5 days. But since I said that that resource was only going to be working at 50% of their time, what project did was it recalculated the total work. It calculated 50% for 5 days is 20 hours, so it's adjusted the work hours. For both the fixed work task and the fixed units task, it didn't have to hold the duration. So what it did was when I changed that assignment units to 50%, it kept the existing number of work hours and just extended the duration. So I'm going to take that back off again. Whoops. Sorry. And now we'll look at what happens when I make a change to the duration. So now what I'm going to do is I'm going to change the duration on each of these tasks from 5 days to 10 days. For both the fixed duration and the fixed units task, what project did was it kept the assignment units that we had already specified, and it said, okay, if I'm working at 100% for 10 days, that's going to be 80 hours. So it recalculated the hours for the fixed duration and fixed units task. For the fixed work task, because the work is being held fixed, what it did was it adjusted the peak unit. So remember, peak represents the current assignment for that task. And I'm actually going to jump over here so that you can see the date over here, okay? All right, so if you notice, the fixed duration, fixed units tasks are still assigned at 8 hours a day. The fixed work task is now assigned at 4 hours a day. All right, so I'm going to pull that back off again. And now what I'm going to do is I'm going to change the work. So I'm going to go into each of my assignments, and I'm going to change the work assignment from 40 hours to 80 hours. Again, fixed duration is holding the duration. So in order to do 80 hours of work in 5 days, the peak is increasing to 200%. For both the fixed work and the fixed unit tasks, what happens when I increase that duration is that, or sorry, what happens when I increase the work is that the duration extends. So now I want to take a look at the effect that the effort-driven value has. So what I've done here is I have a project that this time has 5 tasks. So what it has is all 5 of the different combinations that I can have with task type and effort-driven. So this first one is fixed duration, not effort-driven, fixed duration, effort-driven. Fixed work, effort-driven, because that's the only way it can be. Fixed units, not effort-driven, and fixed units, effort-driven. And you can see the type field here and the effort-driven flag here. So again, what I want to show you is the difference of how these respond when I add a resource, because as I mentioned, the time where you'll see the most impact is when you're adding resources. So I'm going to go in here, I'm just going to select all the tasks, and we're going to learn how to do this tomorrow, so don't worry about the actual steps I'm going through. But what I've done is I've assigned a resource to all of my tasks. So to start out, regardless of how they're set up, I get the same results. They all stay up 5 days. They get assigned 40 hours of work at 100%. Where things change is when I now assign a second resource to each of those tasks. So if you remember, what I said about effort-driven is effort-driven, if I have that flag set to yes, that tells project that I want you to take the existing work and I want you to spread it across the resources. So when I add an additional resource here, what we're going to see is for the not effort-driven tasks, so that's going to be fixed duration, not effort-driven, what that's done is we originally had 40 hours assigned to the design engineer. Because it's not effort-driven, when I added that additional resource, it added the marketing manager at an additional 40 hours and increased the total work. So we see that for the not effort-driven or the effort-driven flag set to no for fixed duration and fixed units. For the effort-driven tasks, what we saw was that the work, the 40 hours, got spread across those two resources. So in all cases of effort-driven, the design engineer and the marketing manager now have 20 hours of work assigned to each of them. In addition, something else had to change. So for the fixed units and the fixed work, what you'll also see is that the duration shrunk. Because we took that amount of work, we spread it across multiple resources, they can get the task accomplished more quickly. For fixed duration, because we couldn't change the duration, we're now doing 40 hours of work, each resource doing 20 hours of work in 5 days, so each resource is going to be assigned at 50% peak value. Okay. Any questions on that? Amy, any questions yet?
Nope, no questions on our end.
No questions. You guys are so easy. Or maybe asleep. All right. So that's basically what I have to go through today. If you do have additional questions, want to find out more about our training that we provide, there's a link on the screen. If you have questions that come to you after the session, please feel free to send those questions in and I can get back to you. Otherwise, I thank you all for being here. We will be back tomorrow to talk in detail about how to use resources in Microsoft Project. So we'll talk about creating our resource pool. We'll talk about assigning resources to tasks. We'll talk about analyzing that information, looking for over-allocations and under-allocations, and what to do if we find them. So I hope you can join us. Thank you.